Okay, our regular weekly updates. Today, October 13th. There's a lot of updates as usual, so this is me. I want to start with these citations from Steve Jobs and Satya Nadella. So Steve Jobs said that computers are like bicycle for your minds. They're helping you, but you have to use your own muscles, right? Satya said, AI is like a steam engine for your mind. Interestingly, that he didn't say that it's something more modern, like a race car or a rocket. So we'll see which will go next. But I just thought it's funny that both of them compared a computer with, Steve Jobs compared computer and Satya compared AI. So like exciting to see what will go next. Okay, some updates. Mistral, remember the company, startup from France, from Paris. They're coming up with new models, and people take these models and make them better. I checked today, there are 45 variations of Mistral models on Hugging Face open source, what is called benchmark page. OpenOrca is now available on Alama. We really like Alama because it's a great way to run models on your computer. It's currently available with GPU support on Macs and Linux, and I highly recommend to use it and play with it. Quality of the models is really good. Something new happened just, I think, today. Mistral 11 billion parameters was released, and it is better than the original Llama with 70 billion parameters when it was released in July. And I expect that after this initial release, there will be new versions fine-tuned on different data sets to improve it. So it's very exciting. Llama can be used with LangChain. So here is a link to a short YouTube video which demonstrates how to do it. But it looks like it's a practical way to go. So you use Python framework LangChain and you use Llama to run the models. Databricks recently bought Mosaic ML for $1.3 billion. So Mosaic ML is a generative AI platform that allows enterprises to build and deploy their own AI models inside their private cloud. Again, it's a platform. So we see a lot of money being poured into platforms. ChatGPT is a platform, right? Okay. Lava, a large language and vision assistant. What's interesting about it, it's comparable in quality with ChatGPT Vision, which I still haven't played with it. But it uses Llama 2, it's open source, it's free. You can install it and use it on your computer. So this is something you can check. So you can give it image and you can ask it to describe it or extract some information or change it. Like it's interesting. Okay, Hugging Face large language model leaderboard. Okay, this is really exciting, right? Let's look at the blue one. It's original Llama 2 when it was released in July. So it has 66.8, it was its average score, right? 70 billion parameters. But now look, there are two models from Mistral. One is 7 billion parameters and one is 11 billion parameters. And they both are better than the original Llama, although they are much smaller, right? Now look at GPT 3.5. It's at 71.9, so it's about 72. How far is it from Mistral 11? It's about 5, right? Now look at Mistral 7B, the current best, and the original. It was 62.4, 67, so it's about 5 difference. So if we presume that Mistral 11 will grow on also by 5 points, it can overcome the GPT 3.5. It's really exciting to see these small models becoming so much better. And the ChatGPT 3.5, I mean GPT 3.5, it is 175 billion parameter model. It's a huge model. It requires like $500,000 computer to run. And here you have models which you can run on your MacBook laptop. So this is really, really exciting news. Next, I want to talk about Inflection.AI and their model called Pi. So what is Inflection.AI? The three co-founders, they're all very famous people. Mustafa Suleyman, he's co-founder of Inflection.AI. He is also co-founder of DeepMind. Well, DeepMind had three original co-founders, and it's a very famous company in Europe, which was bought by Google. They developed reinforcement learning techniques. Famously started with Atari games and then moved to more complex games like chess, AlphaGo, AlphaFold, and so on. Another person from DeepMind is a principal scientist from DeepMind, Karen Simonyan. He's now chief scientist and co-founder on Inflection. And the third co-founder is Reid Hoffman. He's co-founder of Inflection, but he also co-founder of LinkedIn. So we have very strong founders, and they originally raised 225 million in 2022, and then recently they raised another 1.3 billion from some very good investors like Bill Gates, Eric Schmidt, NVIDIA, Microsoft, and so on. So this is a very strong support, right? So what they did, they created a chatbot called Pi. And the idea of Pi is that it becomes your personal friend. It can emotionally support you, it can answer your questions, it can learn about you and become better for you. It's also creative and fun, and it's interesting. Now, on Twitter, people say that this is the worst chat ever because it's trying to be funny, it's trying to use emojis and say ha ha ha, he he he, and so on. So they think it's kind of artificial. But again, it's beginning. It maybe really become something really good, like a personal teacher, coach, confidant, creative partner, sounding board. We'll see. So these are some links to explore about Pi. AutoGen from Microsoft. The idea is to build system of cooperating agents. So you can just install it in Python and start using it. There are a lot of tutorials. People really like it. You will see that it becomes trendy to use systems consisting of multiple agents which cooperate with each other. And you can use it for multiple problems like math problem, multi-agent coding, three-agent solving, optimization problem, online decision making, retrieval augmented chat, dynamic group chat, conversational chess, allowing players to engage in interactive chess game, whatever. There are many examples, you can find and explore them, but so far people really like it. It's open source, although it's coming from Microsoft. I don't know. Like I not a big favor of Microsoft, but recently, as you know, Microsoft was using a lot of open source technologies and creating some really good software. So, okay, mastering customer segmentation with LLM. I haven't provided here more information. This is an article which is interesting because what they're saying, but using combination of clustering algorithm and large language model, you can achieve much better segmentation, right? So this is good. An operating system that boots into Baby Llama 2. So this is really interesting. You have operating system which is called L2E, and you see it here, L2E, when it boots, and it boots into large language model prompt, and then it talks to you. So it's large language model becomes like operating system itself, basically. So instead of shell script, you have large language model prompt. Yeah, it's very interesting. RAG, retrieval augmented generation. This is something I spoke a lot recently, and I posted a short video on LinkedIn. So the idea is to enable a large language model to use external data, And you see it in ChatGPT, in BART, and Bing. What they do, they browse internet, they use web search to retrieve recent and relevant information. So if you ask a question about something recent, which model was not trained on, he can go online, find information, and then give you an answer. If you're doing something for business, like locally, privately, so you can retrieve information from SQL database or from vector database based in similarity search, or you can use APIs to connect to different systems to retrieve information from them. It may be, let's say, accounting system or something else. So the simple diagram is you have the question and eventually you get an answer, but in the middle you have some LLM agents which are getting data from one or more sources and then combine, rank, and provide you the answer using LLM. So this is a more complex representation, although it's still simplified. So let's say you have documents, you split them into chunks, you convert chunks of text into vectors and you load them in the database. Then when you have a search query, you use the same embedding model to create a vector, and then you do similarity search to find similar vectors. You take corresponding chunks of text, which are also stored in the database, and then you take these relevant chunks and you add them into the prompt. So the prompt will have original user query and those chunks, and it will ask a large language model to give the answer based on these findings and give you the answer. So this is a standard RAG, retrieval augmented generation. Does it work well? No. I mean, it works like Elasticsearch, but not really better. And because there are many problems with it. So first of all, what if question and answer are not similar? So vector similarity search will not be able to capture this inferential link between them if they are not similar. Another problem is that one text passage may contain several ideas, but if it is encoded in one vector, it's impossible to distinguish relevant sections from irrelevant ones. And vice versa, some questions demand synthesizing facts spread across multiple documents, meaning multiple vectors. How you do that? So there are multiple ways to improve. One common way is to add metadata, add summaries and tags. So you can actually use large language model to pre-process your chunks or your documents to create those summaries and tags. You can add relationship between vectors based on topics, vector similarity, structural, like for example, connection between sections, pages, documents, temporal, if events link chronologically, or links, maybe document refer to each other between passages. So this is a little bit more complex model, and you see it now includes metadata, summaries, tags, references, and so on. Next topic is fine-tuning large language models. Well, if you're doing something for a business, can you train a model from scratch based on private business data? Well, first of all, business probably don't have enough data, but even so, it's extremely expensive. Training a new large language model, it's millions of dollars. If you train a small model, like 7 billion parameters, it's still like 40 to 400,000, I mean 40K to 400,000K, so it's still kind of expensive. But what you can do, you can take existing model and you can fine-tune it using your data, and this is much cheaper. How much cheaper? Well, depends on the amount of data and the size of the model. If you take smaller model, it will be cheaper. And if you use model quantized to 4 bits, oh gosh, you can actually fine-tune the model on your laptop. PEFT, parameter efficient fine-tuning. Well, this is generic terms and there are multiple ways to achieve it, but the two most often used is LoRa and QLoRa. It's basically the same thing. QLoRa is just using 4-bit representations to make everything smaller and calculations faster. So LoRa was introduced in 2021 by the group in Montreal, in Canada. Well, if you may remember, Jeffrey Hinton is coming from Toronto, Canada, and Yasha Benjo from Montreal. So this is from this epicenter of deep learning. And so they proposed the way to fine-tune the model. And then QLoRa work was done this year, published in May, and it is in Seattle, Washington, University of Washington. And they basically used the LoRa model. They just did it with 4-bit, and there is a little bit of trickery how you do that. They go for zero average and but anyway, these are some details you can pick up in these articles. So this is a description of how LoRa works. So suppose you have your original model, which is a transformer, which is a multi-layer model, and in each layer you have some matrices which are trained during the training of the big model. So these weights you don't change, they're frozen. But what you do, you add another matrix. In fact, there are two matrices, because what you're doing decomposition of, you present one bigger matrix as decomposition of two smaller matrices, like this, A and B, and here, A and B. And these are the matrices you train on your fine-tuning data, on your training data. And because you reduce number of parameters, the training is, and because you don't have a lot of data, right, the training can be very fast. And if you're doing it with QLoRa, which is with 4-bit, it really doesn't take a lot of resources. I recommend I provide these links to this article, Fine-Tuning LLM, Parameter Efficient Tuning LoRa and QLoRa, which like very easy read explaining how this works. And if you go to GitHub, where like from one of the original authors of QLoRa, you will see the code, the tutorial, the video, the examples, how to do it. It's not difficult at all. And yeah, you can just fine-tune your model. And these are two more articles with examples how to do it. So don't be afraid of fine-tuning. It's actually easy to do. Tagging, extracting keywords from documents. Well, there are multiple ways of doing it. So when I was talking about RAG in the beginning, I spoke about creating summaries. So you can simply ask a large language model to create a summary, let's say in 200 words. And boom, you have the summary, and then you store it with your vector. And then you can also extract keywords, and this will be your tags, right? And there are Python modules to do this. So for example, KeyBird is one of the libraries from which you can use functions to extract keywords, and you can say how many you want, and so on. There is also same functionality, similar functionality already built into LangChain. So you can see from LangChain, import, create tagging chain, pedantic, whatever, and you can create the tags. People used to use the TF-IDF for article tag recommender system. And so there's a couple articles you can read about details. I didn't go too deep into this, but it looks like it's a well developed and documented area, and now with large language models, creating tags becomes easy. Now, about hosting a local large language model versus cloud, we already covered it before, that hosting on the cloud is quite expensive, and long term, it's always better to own versus rent. And given that the models become smaller, so hardware needed for running them becoming cheaper, I think for now you better owning it than putting it on the cloud, especially because it gives you a lot of peace of mind. Like for example, recently Azure OpenAI service exposed it 38 terabytes of data, so this was a big scandal. Of course, they said, no, everything is good. But 38 terabytes of data, the whole storage account, including passwords and secure keys. And there are multiple other situations which I've seen recently. So I'm all for local private models. So same with hosting your own embedding models. You absolutely can run them and they will be good quality. Third AI Labs. This is interesting project. It's on GitHub, but it's not open source. And what they say is that if you're using a vector database with embeddings, you achieve a certain quality of your RAG, of your retrieval augmented generation, right? Which is close to what you get with Elasticsearch. But if you fine tune your model and if you use user feedback, you can actually achieve much better quality, much better accuracy of your model. And that's good, and they demonstrate it with their own system. I just wish it would be open source, but you can recreate something like this yourself. It's just the idea that counts, that it's better to use model which was fine-tuned on your data and used human feedback to become better over time. A little bit more miscellaneous automating ontology construction with LLMs. Remember when talking about improving RAG, I was talking about connections between different chunks, and they may be in fact grouped into some ontology. So giving your documents how you create ontology from them to help you in your later data retrieval. So this article talks about that. LangChain expression language. This is something new. They refactored. LangChain is a Python framework to work with large language models, vector databases, different APIs to different systems. So they now rewrote every agent to make it like more flexible and more easy to modify using their own like LangChain expression language. Next point is very, very important. And this is making AI hallucinate less with chain of verification. So what it means is you have a question and large language model gives you the answer, but you don't stop there. You ask large language model to suggest 2-3 questions to verify the key facts. And then you ask these questions and you get the answers. And what's interesting, if the questions are narrower, like more factual, more focused, the probability of hallucination is much less. And you can get to the truth using these additional questions. I think it is similar to Plato, it's an ancient philosopher, Plato, way of getting to the truth by asking questions. So this is, I think, very interesting approach, and they improved significantly what you see by 38%, 5 times over baselines, 28% on different metrics. So this is definitely something we should know that it works and use it. And the last slide is about RAG fusion. And again, simple technique, but looks like provides good results. Unfortunately, they didn't provide the actual metrics. But the idea is you take the question and you create multiple variations of these questions. And you ask all these questions, and each question will give you something from the vector database. And then you combine them all together, and then you create the answer. This article actually, it's all on GitHub, but they provide this graph, which I really like, which shows interest in RAG and how it is skyrocketed in 2023. You see, this is April 2023. So it was flat and then it started to grow very much. So there is this argument between fine-tuning and using RAG, right? So RAG is limited, but with fine-tuning it becomes better. But you cannot really use just fine-tuning, because models always tend to give you the most probable answer, right? And suppose you modeling legal documents and you have 100 contracts where like certain clause in written the certain way, and then the 101st contract is opposite. So the model most probably give you the most statistically like average answer, not the particular one. So I think you need to use both. You need to use RAG with specific data, and you need a model to help you to formulate the answer. Okay, this is the end for today. Thank you.